Question number 2. On the same axis, sketch the curves with equation y is equal to 6 divided by x and y is equal to 1 plus x. The curves intersect at points A and B. Find the coordinates of A and B. So we have two graphs intersecting. The first graph is y is equal to 6 divided by x, and the next graph is y is equal to 1 plus x. So the first graph, this one is a reciprocal graph. We can sketch it. It's a positive reciprocal graph. So it will be somewhat like this. This is our x, this is y, and this is origin. The second graph is a graph of a straight line with positive gradient and y-intercept as 1. So this is y-intercept, which is 1, and the graph has a positive gradient. So this is the graph of y is equal to x plus 1. Now the two graphs intersect at points A and B. So here are the points where the graphs intersect. Let's call this A and this one B. Find the coordinates of A and B. So when we want to find the coordinates of point of intersection of two graphs, we equate the two graphs. So here we already have y as the subject of formula. So y is 6 upon x and y is 1 plus x. So we equate 6 divided by x is equal to 1 plus x. Take x, multiply it on the other side. 6 is equal to x into 1 plus x. Therefore 6 is equal to x plus x squared. Bring everything on the one side. So we have x squared plus x minus 6 is equal to 0. Our product is negative 6. Sum is the coefficient of x. So the numbers are 3 into minus 2. So factors are x plus 3 into x minus 2 is equal to 0. Therefore x is equal to negative 3. X is equal to 2. So we got the x coordinate of the points of intersection of the two curves. So let's write, this is in the third quadrant, so this will be negative 3 for x, and here x will be positive 2. Now we need to find the corresponding y coordinates. We can use any one of the two equations. So let's use this equation here. Y is equal to 1 plus x. So we can find the corresponding y coordinates. So we have minus 3 as x. So minus 3 plus 1 will give us minus 2 here. And for the next one, we have 2. So 2 plus 1 will give us 3. So those are the coordinates of the point of intersection. The part C of the question says the curve C with equation y is equal to x squared plus bx plus q, where p and q are integers, pass through points A and B. So there's a curve which is a quadratic curve, passes through the points A and B. So it's somewhat like this. It passes and it's quadratic. So let's sketch the curve. Okay, so the curve is passing through the points A and B, and the general formula for the curve is y is equal to x squared plus bx plus q. Now we need to find the value of p and q. Since the curve is passing through the points A and B, that means the points A and point B satisfy the equation, which means if I take this point and I plug in for y negative 2, so for y I plug in a negative 2, alright, and for x I plug in a negative 3, so I can find the value of p and q by substituting both of these points. So let's substitute first the point A. So y is negative 2, x is negative 3, so negative 3 squared, plus bx, so it's going to be minus 3b plus q. So that gives us minus 2 is equal to 9 minus 3b plus q. Therefore, minus 3p plus q is equal to minus 11. Similarly, if we plug in the other point b in the same equation, for y we will plug in 3 and for x 2. So let's plug in for y 3. 3 is equal to 2 squared plus 2p plus q. So we have 2p plus q is equal to 3 minus 4, which is negative 1. So we have two equations in terms of p and q. We can solve them simultaneously. So we have minus 3p plus q is equal to negative 11, and 2p plus q is equal to minus 1. We can eliminate the variable q, so by subtraction, so this becomes minus, and this is positive. Minus 3p minus 2p gives us minus 5p. Q and negative q are eliminated. Then we have minus 11 plus 1, which is minus 10. Therefore, p is equal to 2. Now we can plug in the value of p into any one of these two equations to get the q value. So let's take the second equation. We have minus 1 is equal to 2 into p, so 2 into 2, plus q, so minus 1 is equal to 4 plus q. Therefore, q is equal to negative 5. So p is equal to 2 and q is equal to negative 5. Therefore, this equation that we have, it is now y is equal to x squared plus 2x minus 5. Question 3. The diagram shows a sketch with curve y is equal to f of x. Point B, which is 0, 0, lies on the curve, and point 3, 4 is a maximum point. The line y is equal to 2 is an asymptote. Sketch the following, and in each case give the coordinates of the new positions of A and B. State the equation of the asymptote. So now in this question we will see what are the transformations from A to F. The first part of the question is the function f of 2x. Now this function f of 2x divides only the x coordinate, and the x coordinate, all the x coordinates are divided by 2. The y remains unchanged. So let's see the transformation in all the coordinates. So this coordinate 0, 0, when its x value divides, it remains 0. So for A, the coordinate 0, 0 remains as 0, 0. And the coordinate 3, 4, the x coordinate will divide by 2. So it will become 1.5. Y will remain unchanged. And since this is the y asymptote, it will remain unchanged. So y is equal to 2. So the graph will be 0, 0 will remain as it is. Point 3 will be at 1.5. So 1.5, and the asymptote will remain as it is. Question B is half of fx. Fx is y, so half of fx means the y coordinate will be multiplied by half. X will remain unchanged. So 0 into 0, 0, 0 will remain as it is, because 0 multiplied by anything remains the same. For this point, the y coordinate will be multiplied by half. So x remains the same, y becomes 2. And the asymptote also multiplies because it's y coordinate. So it will be y is equal to 1. So the graph will start from 0, 0. It will go to 3, 2. So in place of 3, 4, it will be 3, 2. So this will be the highest point. And the asymptote will be y is equal to 1. That answers B. Moving on to C. Question is f of x is minus 2. This transformation takes the graph 2 steps down. So where the graph is starting at 0, 0, it will start at 0, negative 2. And all the y coordinates will shift down because it's as if the graph is just shifting down by 2 steps. So this point will be here 2 steps down, which is 0, negative 2. 3 comma 4 will become 3 comma 2, and the y is equal to 0 will become, this will also move 2 steps down, so it's going to be the x-axis will be the new asymptote. So let's write our transformation. 0, 0 will become 0, negative 2. 3, 4 will shift down, y coordinate becomes 2, and here the x-axis or y is equal to 0 is the asymptote. Question D, we have f of x plus 3. So f of x plus 3 means the graph slides to the left by 3 steps. So this point here goes 3 steps to the left. So it becomes negative 3, 0. So we have negative 3, 0. And this point here moves 3 steps behind, so it becomes 0, 4. 0, 4. The asymptote is y is equal to 2. So the graph will start from here, and this will be the highest point, and it will be like this. Moving on to the next one, that is E. E is f of x minus 3. So this takes the graph 3 steps to the right. So 3 steps to the right means this point will start at 3, 0, and this start 3 plus 3, 6, 4. So the graph will start from here. This will become 6, 4 because the x coordinate will add 3 and the asymptote will remain the same. So the x coordinate will be 3, y will be 0. Here the x coordinate will be 6, y will be same, and the asymptote will remain the same. Question F is f of x plus 1, which means the graph slides up by 1 unit. So what is here at 0, 0 will be at 0, 1. So the y coordinate moves up by 1. 3, 4 will go to 3, 5. Okay, so the graph will go like this, and hence the asymptote will also become y is equal to 2 plus 1, 3. So f will be 0, 1 and 3, 5, and the asymptote will be y is equal to 3. Question number 4. The diagram shows the curve with equation y is equal to 5 plus 2x minus x squared. Since it's minus, the curve is inverted. And the line with the equation y is equal to 2. So the curve is being intersected by the line y is equal to 2. The curve and the line intersect at the points A and B. Find the x coordinates of point A and B. So we need to find the x coordinates. We already know that the y coordinates are 2 because it's a straight line passing. So in order to find the x coordinates, all we need to do is we need to equate the two equations since both of them have y as the subject of formula. So first is y is equal to 5 plus 2x minus x squared, and the other one is y is equal to 2. Equating the y equivalents, we have 5 plus 2x minus x squared is equal to 2. Bringing everything on one side, so we have x squared minus 2x minus 5 plus 2 is equal to 0. Therefore, x squared minus 2x minus 3 is equal to 0. A product is negative 3. Sum is equal to negative 2. The numbers are 3 and 1 with negative 3 and positive 1. So our factors are x minus 3 and x plus 1. Therefore, x is equal to 3 and x is equal to negative 1. So we got our x coordinates. For point B, x coordinate is 3 and y coordinate is 2. And for point A, x coordinate is negative 1 and y coordinate is 2. Question 5. The diagram shows a sketch of the curve with equation y is equal to f of x. On separate axes, sketch the curves with equation y is equal to negative x and minus of f of x. So we have the curve here already drawn for us. This is the graph of y is equal to f of x, and we need to do the transformation as per y is equal to f of minus x. Now, quickly to understand this transformation, if x value is negated, so for example, I have an x coordinate here 2, 3. So my x coordinate is through 2. So when my x coordinate is negated, it becomes minus 2. So this is minus 2, 3. So this is as if there is a reflection in the y-axis. So this, in other words, reflection in y-axis. So this reflects in y-axis. So if the graph reflects in y-axis, what is on the right goes to the left and vice versa. So the graph will be like this and like this, just the other way around. So what is here comes here, and what is here goes here. So the graph will be like this. So that answers part A. Moving on to part B. So part B is y is equal to minus of fx. Fx is nothing but y. So when we are doing minus fx, we are negating the y value. So let's quickly understand. If we have a coordinate, say again 2, 3, and if you want to negate the y value, the point will go to 2, negative 3. So when we negate the y value, it's as if we are making it reflect into the x-axis. So this is nothing but reflects in x-axis. So the whole graph will reflect in x-axis, or it's as if the x-axis is the mirror line. So it's going to be like this. Question 6. The diagram shows the graph of quadratic function f of x, which is given here. The graph meets the x-axis at 1, 0, 3, 0. So these are the x-intercepts. And there's a minimum point given, which is 2, negative 1. Find the equation of the graph in the form of ax squared plus bx plus c. Since it's quadratic, it's going to be a square equation. So we'll answer the first part. So let's see, we have our coordinates given. So we will use our coordinates or x-intercepts. So we are going to work from the end to the beginning. Since we have our x-intercepts as x is equal to 1, x is equal to 3. So our equation can have, right now it is in the form of y is equal to ax squared plus bx plus c. So when we use the points 1 and 3, we know that our equation is in the form of some value a and x minus 1 and x minus 3. Because then if we have x minus 1, so it will be, when it's equated to 0, it gives us x is equal to 1. And x minus 3, when it is equated to 0, it gives us 3. Now, we have plugged in these 2 points. We also have a third point, 2, negative 1. We can also plug this in because this also lies on the graph. So plugging in our third coordinate, y value is negative 1. A we don't know. X value is 2, so 2 minus 1. Here again x value is 2, so 2 minus 3. So we have minus 1 is equal to a into 1 into negative 1, or minus 1 is equal to a times negative 1. Minus 1 divided by minus 1 gives a. Therefore, a is equal to 1. Now we know our equation, it is y is equal to 1. A is 1. So then we have x minus 1 into x minus 3, which can be written as x squared minus 4x plus 3. That answers part A. For the part B, we have on a separate axis, sketch the graph of y is equal to x plus 2. X plus 2 is a transformation where the graph slides left by 2 steps. So if this graph slides left, what is here will go 2 steps behind, which means it will pass through -1, and 3 will go 2 steps behind, so 3 will become 2 and 1. So -1 and this. And our minimum will be, also will step 2 steps behind, so minimum will be on the y-axis. So this will be -1, 0, -1, and 1, 0. That will be the answer for the first question. Second is y is equal to f of 2x. F of 2x means all the x coordinates are divided by 2. So the x coordinate here will become half, and the x coordinate here will become 1.5. And the x coordinate here will become 1. So this will pass through half, 1 and 1.5.